And today on the bench, we have a Voodoo2 from Diamond. This is a 8 megabyte Voodoo2. And we have some issues here on this chip, which misses some pins. This is the FBI chip. And I think this entire bottom row needs rework. We will see this under the microscope in a moment. But first, let's check if we have some issues with our caps on this board. Here is my multimeter. Let's quickly check what we get on the 5-volt line. And we have 35 kilo ohms approximately, so this is fine. Let's check the other two. So this is the 3.3 volt, 300 ohms. This is okay. And this is the adjust pin. Perfect. Okay, so we have no problems on this card with capacitors. But now we need to go under the microscope and have a look at this row of pins. Now, what I understood, the owner tried to fix them, but at some point he realized that, okay, he's doing more harm than helping. And he reached out and I said, yeah, I'll have a look at this card. So let's see what we find under the microscope. Okay. So I think this pin was maybe loose. I have to check this. I probably have to remove it and reattach it. But the main issue that I have here is actually that all of these pins on the bottom row are misaligned. Look at this. This would be a lot of work to straighten these. Yeah, here's one cap missing, and I think there's more. I've seen something else here. I think, yeah, here is a cap missing. Yeah, I'll do this off camera. It's just caps, 100 nanofarad caps. So just because maybe I'll lose this pin, the question is, do we reattach this pin or do we use a wire? And I would definitely go for a wire because this pin broke at the length of the pin. Basically, there is no overlap. If I put a wire there, I can at least overlap the wire with the rest of this pin that's here, the stub, and I have more surface to reattach this connection. And why do I know this? Well, it is not my first time to reattach pins on Voodoo cards. Of course, PCBWay opened the door for me to explore more than simply soldering copper wires to broken metal stubs. The Voodoo memory boards, for instance, which ironically require soldering copper wires, or the more advanced memory boards for all 64 sound cards. It was so much fun designing PCBs that I ended up with 4 different versions. Different memory chips, different dimensions and layouts, but with one goal: to make inaccessible features available to everyone. This is why you can find all my PCBs on PCBWay's shared projects website. Ordering from PCBWay is super easy. Upload or pick your Gerber files, set a few parameters on their user-friendly interface, and within a few days you have your new PCBs in hand. PCBWay can also print your 3D designs. I once got those trays for organizing my CPUs. Now I know exactly where to look for when I start a new project. Whether you need PCB assembly, CNC machining or even injection molding, PCBWay is a true one-stop shop. So check out PCBWay to kickstart your next project. Links are in the video description. And now, let's see if we can revive this Voodoo2. Okay, then let's try to get this entire row straightened. This solder is not that nice. Let's see if we can fix this too. Much nicer. Okay, before we continue, let me just get rid of as much of the existing solder as possible because this doesn't flow nicely, this solder. I have a feeling this is non-leaded solder, and that is why it's so hard to make nice solder connections. Okay, I think we finished this row. I still have to reflow the solder properly, but we aligned all the pins. Some of them are not yet attached to the pad. I really think this was non-leaded solder that is on these pins right now, which makes it extremely difficult to rework. This requires more heat and yeah, the solder doesn't flow as nicely compared to leaded solder. I believe we are done. Okay, card is in the system. Let's see if everything works. Okay, that's a good sign. I think we'll check Mojo immediately. This will give us immediate confirmation if the card is working or not. Will it detect our Voodoo2 with 8 megabytes? No. Wow. Did we not see it when we posted? I didn't pay attention. No, there should be a multimedia device. Okay, I'll clean the contacts and then let's see if this Voodoo works. Because maybe there's just something going on with the PCI connector. Haha, multimedia device. Nice. It was just the PCI connector. Let's see if Mojo actually detects it now properly. Nice. Our Voodoo2 is working. Okay, mandatory, I think. Let's go to Windows and, well, play a few rounds of Unreal Tournament, I believe. Oh, wow. So this is clearly an issue with memory, and that might give me actually a chance to try something new that was shared with me. I haven't said anything about this yet because I unfortunately didn't have the time to look at it, but maybe this is the perfect time to check a tool that is similar to Witchery. Actually, if you weren't aware, Witchery is released publicly, so you can go to this Vogon's post and you can download Witchery and test your Voodoo2 card. This is a really good tool to figure out what's wrong, but I want to try something else. Okay, and here we load from the live CD, and once you loaded the live CD, you will end up on this desktop, and you even have access to Unreal Tournament. Of course, I tried this, seeing if I can reproduce the artifacts that we got before, and wouldn't you know, we get exactly the same issues. Next to the Unreal Tournament icon is the link to an application that we're actually interested in, the V2 TMU Mem Tester. Once you double click, you will get the terminal, and then you just have to type in V2 TMU Mem Tester, hit enter, and let it do its magic. You will get some test patterns, and there are a lot more options that you can pick from, but this is not for me to discuss here. This is something that you can look up when you're downloading the tool or read through the README. So, and as you can see here, the tool definitely found issues. And I scroll up, yeah, I get the summary here, and immediately we can see it detected the FBI memory with 4 megabytes. That's great. Then we have the TMU memory, which is at 2 megabytes. This is correct, it's an 8 megabyte card, so we only have 2 megabytes per TMU chip. But TMU1 only registers 1 megabyte. This is very different from what we've seen in Mojo. So Mojo didn't really tell us the truth. It looked like everything is fine, but no, it isn't. So yeah, this is already a very big hint that we have an issue with TMU number 1. This output alone takes out a lot of the guessing game already. So of course this is something that I had many times in the past, and the first thing I did was to reflow the pins around the TMU chip. So I'm trying to fix one issue at a time so that I know if I fixed the issue, it was what I did last. If I fixed 10 things at once, I wouldn't know which one solved the problem. Unfortunately, this didn't fix it. I still had the same issue. So we eliminated one possibility, a bad connection from the TMU chip. Before we continue removing memory chips, I'll try to go through these resistors, specifically the ones that seem to be connecting to memory. So this is our TMU number 1. This is the left one. This is TMU number 0. This is TMU number 1. So what I will do now is I'll just try to beep these low value resistors. Okay, so these ones are good. I can hear the beep sound. You can see the resistance. It's around 20. So this one, I don't see the resistance right now. I'm just listening to the noise. So they're all good. So far, everything seems to be okay. Okay. Yeah, I don't think there is a problem here. Unfortunately, because the memory chips look good. I checked the solder connections. Everything looked fine. Yes, okay, okay. Okay, now 47. Hey. No sound. Interesting. And no measurement. What's going on with the 47 ohm network? Did we find what's going on? 50. Okay, so this one is okay. What about this one? No. This one is dead. 50 is okay. Oh, the next one also doesn't work. And this one? Okay, so this resistor network seems to be damaged. Interesting. So this is, I think this is the first time I have an issue where the resistor is actually at fault. No connection. This one had 50. No connection. Third one also no connection. And this one also had 50. Okay, wow. No crack, nothing. Okay, I couldn't find an exact match, but we have 56 ohms. So I'll just use one of those as a replacement. I think that should be fine. $56. Okay, so my multimeter beeps at 50 apparently. 56, 56, and 56. So let's test if this card works now. Okay, now the big moment. Is this Voodoo2 fixed? Or do we have to go back and find more faults? And here we are, no errors anymore. And as you can see on the very top, we see TMU 0, 2 megabytes, TMU 1, 2 megabytes, memory detected. So this was it. We just had a bad resistor array. Now this tool confirmed that it looks like everything is working, but of course we have to go and see if it really works under Windows 98. If you want to get a copy of this memory testing tool, please go to the video description. You will find a link. It will be available when this video is going live. And yes, this is a complementary tool to Witchery. Witchery is very good in identifying issues between RAMDAC, FBI, FBI TMU, but it can't test the memory. Now we'll see if the issue is fixed. And then, well, you have another tool to fix your Voodoo2 cards. Oh my goodness. It looks perfect. Our Voodoo card is fixed. So yeah, this is all I have for today. I hope you enjoyed the video. If you did, please hit the like button. Also subscribe to my channel if you haven't already done so. And I also want to thank PCBWay for sponsoring this video, and also all the people who are supporting Bits and Balls here on YouTube and over at Patreon. If you want to become a supporter, head over to Patreon or become a member directly here on YouTube. You'll get early access to my videos and you will get access to my Discord server. Thank you so much for watching, thank you for your time, and I hope I will see you in my next videos. Take care and bye bye.